Alright, so this is the last ones, I think. That's number 7. The initial culture size by 0 is 1,000. So we start off with 1,000. And it goes for, after an hour, bacteria goes to 8,000. So we need to find that B, the rate. So after 1 hour, we're going to say, we say T is equal to 1. It's 8,000. Okay? So it means our rate is 8. Right, so you solve for B, so you divide both sides by 1,000, you get 8. So the equation is going to be 8,000 times 8 to the T power, where T is in hours. Okay. So find the population after 1.5 hours. Well, it should just be 1,000 times 8 raised to the 1.5 power. And that is, let's see, calculator. It's 1,000 times 8 to the 1.5 power. That will be 22627. All right. Um, Next question says, when would population reach 15,000? All right. So on 15,000 is equal to 1,000 times 8 to the T power. So now you just got to solve for T. So you divide both sides by 1,000. So we want to get T by itself, right? So we have 15 is equal 8 to the T. Alright, so you know how to solve for this. Go back up here. So that's 15 is equal to 8 to the T. Remember, anytime you're solving for exponentials, the best way is just to use logs. So you take the natural log of both sides. So you have the natural log of 15. You are using the laws of exponents. So you have T, the same. Natural log of 8 to the T is the same thing as saying T times the natural log of 8. So now we can just do a little bit of algebra again. We divide both sides by natural log of 8. Divide by the natural log of 8. So we have T is equal to the natural log of 15 divided by the natural log of 8. And that is going to be, let's see, natural log of 15 divided by natural log of 8. It's going to be, let's see, it's 1.3. 1.3 hours. Let's go ahead and plug that in just to be sure. This is 8 raised to the 1.3. Gives you 14.92875. So that's pretty much, that's pretty much 15,000 right there. Alright, so that works out pretty well. Next, let's sketch the graph of the population. Alright, so we sketch the graph. So again, when T is 0, you know you start at 1,000. And it just goes up exponentially. When this is 1, this is 8,000. Alright, so it just goes up really, really fast. The reason why we don't graph, there's nothing here, because you don't know what it was before times 0. So you don't ever draw anything here. It starts at 0. It starts at 0 and then it just shoots up. Okay? It just shoots up. So please do not draw this. This will be wrong. You start at 0 and you just shoot it up. Okay? So that's it for number 7. So now number 8. Suppose you have $12,000 in investment. Alright, so now when you have your investment, it's just your principal or whatever you have plus the rate divided by the number of compounds times the number of compounds times the time. Okay? So like compounds would be yearly, semi-yearly, monthly, bi-monthly, weekly, bi-weekly, daily, every hour, every second, whatever. But this is the basic formula. So number 8 says, so you start off with $12,000. So here's 1 plus, the rate is 5.60. So you convert that to decimals. So it's 0.056 per year. Alright, so per year says 1 year. So it's n over t. Alright, so that's just 1. Write the formula counted to years, it is compounded monthly. Okay. So if we're going to compound it monthly, since we already have time in years, how many months are in a year? Well, that's 12. Again, how many months in a year? So that's going to be 12. Okay. So we have $12,000 times 1 plus 0.056 divided by 12 raised to the 12t power. If we simplify that, which is 1 plus 0.056 over 12, you're gonna get that. But this is essentially correct. I'm pretty sure he's not gonna be a butt and ask you to simplify this any more than you need to. I'm pretty sure he's not gonna ask you to write it this way. I've never had a professor tell me to write it this way. This is the way they always want it to be done. Okay. So again, it's the rate divided by the number of times they want you to do it. So monthly is 12, yearly is 365, and so on and so on. All right. So now we have find the amount in the account after 3 years if the interest compounded daily. So find the amount in the account. So we have $12,000 again starting with. So that's 1 plus 0.056. So now he says daily. Daily is 365. You raise that to the 365 t power. So it's set for 3 years. So for 3 years, this is $12,000. 1 plus 0.056, 365th power times 365 times 3. So let's go ahead and just plug that into your calculator. Let's see, you get you're gonna get, come on calculator, turn around. So you have 12,000. Look, this shit ain't gonna fucking work. Alright, 12,000. 1 plus 0.056 divided by 365 versus 365 times 3. Nope, that ain't gonna work. Alright, 365 times 3. Oh, shit. 1095. So we got 1095. 1095. Alright, sorry guys, I'm using my iPad to do this stuff. I hate touchscreens. It's not gonna work. Whatever. You just put that into your damn calculator, and don't worry about it. I mean, that's pretty simple, straight calculation. So you just plug it into your calculator. Make sure since you said 365, you put 365 in your denominator as well as in the exponents. Okay. See if it worked now. Nope. Alright, whatever. Alright, it's still not working on my calculator. Alright, so just go ahead and do the next one. The next one says, how long would it take for the amount in the account to grow? 28,000, and the interest rate is compounded semi-annually. So semi-annually means it's going to be just compounded twice. So you have 20,000. That is your final one. So you have $12,000 at this interest rate. Compounded semi-annually just means 2. So you have 2t. Alright, so now we're going to do algebra and just solve for t. So we divide both sides by 12,000. We have 20 divided by 12. That reduces down to 4 and 5. That reduces to 5/3. So 5/3 is equal to 1.1 plus 0.056 over 2 times 2t. Alright. So now you go ahead and again take the log base of both sides. The natural log. So you have natural log of 5/3 is equal to 2t times the natural log of 1 plus 0.056 over 2. Alright, so remember this is just a number. So you have 2t in this. So you want to divide everything. You're going to divide everything by 2 over the natural log of 1 plus 0.056 over 2. Again, I don't have my calculator, so I can't simplify this. So we have t is equal to natural log of 5/3 divided by 2 times the natural log of 1 plus 0.056 over 2. Alright. So again, they want to see how long would it take to get 20,000 started off with $12,000. So pretty much saying that this needs to equal to 5/3. So you take natural log of both sides. By law of the exponents, you bring this to the front as well. And you just keep doing algebra from there. Alright. The next one is about half-life. So half-life just means, so 0.5. Doesn't matter what you start with. You know it's going to be half of it. So you want to just find the rate. So it says the half-life is 0.5. Is a half-life of is 10 seconds. Okay? So in 10 seconds, it gets half. So you want to solve for b. Best way to solve for b is just you want to get rid of the exponent. So you take the 10th root of this. So the 10th root of 0.5 will give you your rate. All right. That's gonna be a really small number. Really small number. So it is the 10th root of 0.5. No. 10th root of 1/2. Piece of shit. So 1/2 raised to the 1/10th power. What the hell? Stupid phone. Why don't you work? I guess it doesn't do exponents on the stupid iPad. Alright, well fuck it, whatever. Whatever you get is what you get. Alright. So that's B. So that's gonna be our number we're gonna keep using. So next says find the function of models remaining after starting t seconds. So again is just 0.5 to t over 10. It's pretty much gonna be our half-life. I think I'm doing this right. I hope. I don't know, I'm sleepy, so hopefully I'm doing it right. Alright, so this is your half-life equation. Yeah. Because in 10 seconds, yeah, okay. How much would be remaining after 1 minute? So after 1 minute, so after 1 minute, so it'd be 3 times 1 minute 60 seconds. Oops. So it's just to be 3 times 0.5 to the 6. Alright. So after 1 minute, so there's 3 grams of it, so it'll be 3 times 0.5 raised to the 6th power. After that, there will only be 0.046875 grams of it left. Okay, works out pretty well. Makes sense. When will the amount remain to 1 microgram? So you want this to be 10 to the negative 6. So after 3 to the 0.5 t over 10th power. So again, you're just doing math. Divide both sides by 3. So you have 10 to the negative 6th power divided by 3 is equal to 0.5 to the t over 10th power. Raise this to the 10th power. So get rid of this. So you have 5t. Then take the t down, so you take the natural log of both sides. So natural log of there, natural log of that. So you're gonna have t is equal to the natural log of 10 to the negative 6 divided by 3 raised to the 10th power divided by natural log of 5. And that's how long it's going to take, which won't be, that's going to be a pretty big number. Just make sure you put the negative 6 power. Alright? Alright, so for the next one, earthquake, so Richter scale. So you just want to find a proportion. So you want to find how much intensity it is. So if you do this, we use the formula as the log of the intensity of the highest one, or the first over the second, and that's going to be the difference. The difference of the two scales you have. So you have the natural log of the intensity should be equal to 6.4 minus 3.1. So you have log of I1 over I2. That should give you, was that 3.3? Alright, so you want to find the ratio, right? You should solve for the ratio. Because like, I get $10, you get $5. How much more did I get? I got twice of that, right? So I got 2 more as you. So it's the same thing. So you want to find the ratio between I1 over I2. So we need to get rid of the log. Best way to get rid of the log is to raise it by the 10th power. So you have the ratio of the first over the second. It's just 10 to the 3.3 power, which is around, let's see, so the calculator again, hopefully it works this time. 10 to the 3.3 power. To the touchscreen. It's about 1,995 times as strong. Stronger, more intense than that. All right. Again, I know this one pretty fast, but it's just algebra. You're just solving. So you want this equation to equal to this. So equal to 10 to the negative 6 power. So you got to solve for t. So you divide both sides by 3. Raise everything to the 10th power because you got to get rid of this power first. And then you do the natural log thing that we've been doing. Make sure you, make sure you divide by the 0.5. Yeah, 0.5. Alright, that's pretty much it.